Good afternoon to you. Mark out of HurricaneTrack.com here. Hurricane Outlook and discussion time. It is now Wednesday, the 21st of October, 2020. And boy, did Epsilon overachieve. I had a feeling that it would. I've seen too many systems in that area that have done so. You think about Ophelia a few years ago. I can't remember exactly which year. But Hurricane Ophelia definitely overachieved in this vicinity. Sometimes when these systems get into the subtropics like this, they do magical things and they really intensify despite sort of a weird overall background environment. They are able to really intensify, and in this case, Epsilon has done just that. Hurricane Center issuing a special advisory update. Special products have been issued, they said earlier today, that it is rapidly intensifying. We saw that on satellite, but then Recon went out there. The folks from the Air Force Reserves did. And they found that the winds were near 110 miles per hour, the air pressure down to 959 millibars, and the Hurricane Center indicating that Epsilon could become a major hurricane later today. I still stand by my prediction yesterday that this would make it to at least 120 miles per hour. I think that's going to happen. We'll see. Nevertheless, even if it doesn't, and let's say it makes it to 115, I mean, it's at 110 now. I mean, come on. That's pretty good, and this just comes from experience. I will brag just a little bit. The overall experience of seeing systems in this vicinity in the past and the background environment. There's just a little bit colder air in the upper atmosphere through this region in here. It makes the thermodynamics more pronounced. It's not your classic setup where you had a tropical wave come off Africa. It became a hurricane over here, milled around a little bit, and then now it's up in the subtropics, from a heat source that originated as what we call an AEW, or African Easterly Wave. Epsilon came from an old frontal boundary mixed up with an upper level disturbance that worked its way down to the surface. It's kind of your atypical way to develop a hurricane, but it is over warm water. There is some upper ocean heat content. It is definitely a hurricane, but it's just a little bit different in how it got there. You know what I'm saying? And so that environment, as sort of unique as it is, I think is going to allow it to strengthen even further. And you can kind of tell in the modeling, and I'll show you that in just a moment. First of all, a satellite animation here courtesy of Tropical Tidbits. And this is a good example of this. Okay, so you've got a large area of this outflow that you can see. There's anticyclonic flow in the upper levels to some extent, but then there's this huge cyclonic swirl, almost like like you curl up a cinnamon roll, you often hear people say. This big dry slot that's worked in, and then right in the middle of all of this, kind of protected in there, is this beautiful, meteorologically speaking, warm core hurricane. And it's just a little different setup. It kind of looks like Sandy did before it made landfall up in New Jersey back in 2012. It reminds me of that. It's not the same setup, but again, this is just not your typical way where you get a piece of energy like one of these tropical waves down here. Yeah, you remember like Paulette and Teddy. They came from African Easterly Waves, and they came up here, and Paulette went right over Bermuda. You've seen that before. You know what I'm talking about. And this is just a little different. Nevertheless, though, here's a great close-up of it, this GIF animation. I mean, it almost looks like it's computer-generated in terms of the whole thing. It is computer-generated. A computer made it. But it's a real satellite animation. It's real cloud shots stitched together in a GIF animation. This was put together by Kari over in the UK, one of our Patreon supporters. And all that lightning that you see in there, this is part of the lightning detection system of the GO 16 product, and it's just remarkable. It really is. And so the core, the central dense overcast of Epsilon in here, is protected inside of this environment. The eye is warmer than the outside area. It's just incredible. The meteorological thermodynamics, the fluid dynamics, all the upward motion that's going on over here, the instability. And when you see all this lightning in here and that bubbling of the atmosphere, it tells me that there's got to be a pretty large amount of cold air in the upper atmosphere. Cold over warm, and the warm goes up, it bubbles up into that cold, it creates buoyancy. It's just basic meteorology. It's part of how air parcels lift. And in this situation, I think the atmosphere is colder than we are used to seeing, and that's really helping things. In other words, what we're missing with really warm, deep sea surface temperatures below Epsilon and a classic tropical wave structure we're making up for, still getting that heat engine to go. It's just the instability is really significant with this, and it's just a marvel. You got to admit, that's pretty incredible to look at. Anyhow, recon went out, they checked it out, and we find that it is almost Category 3. Now, there was a question. I'm just going to back out to the wider picture, kind of let you look at this. One of our supporters and good friend of HurricaneTrack, his name is Cecil, from the Piedmont of North Carolina. He was asking, and he's asked this before, and I'm paraphrasing here, but why does recon, the United States, foot the bill, whether it's the Air Force or NOAA, going out into storms that are way out in the Atlantic like this, and provide this recon data, etc.? Are other countries helping to support that, kind of part of the WMO, the World Meteorological Organization? You know, I don't know the answer to that part of the question, but I do know, to kind of help answer Cecil's question, why would you fly recon out to a system, and I assume they left, let's use a different color so it'll show up, let's use red. I assume they left from Keesler. I mean, they might have left from St. Croix down here, but let's just say they left from Keesler today and flew out here, and they did their alpha pattern through there. Why on earth would a C-130J, I think it's the J model, go out there and do that? You know, when it's not going to affect land directly. It's not a direct threat to Bermuda. Well, the answer is research, training, and using the budget money that's been allowed for this year. And I kind of joke about that, but it's not just about go check that storm out because it might affect land. They do a lot of research. They test equipment. They test the different pilots and different meteorologists. Some of these people I know personally, and they get certified. And so you use these systems, even if they're far from land, to do training. But in terms of whether or not other countries support the budget, that is a great question. And I think I know who to ask if I can get an answer. It may be too deep in the bureaucracy to get an answer. So we may not ever know, or it may be very readily apparent. But it's a great question that Cecil asked when it's not threatening land. Why even bother? There's a lot of reasons. A lot of research can be done, and even if it's in the open ocean. So again, what a marvelous satellite animation here of this. Thank you, Kari, for putting that together. So, going to our super tracking map, and I'm going to brag about it every chance I get because our good buddy Will Woodgate put that together for us out of the goodness of his heart over in the UK. He's one of our patrons. And the layers on here, this is what you get if you're part of our Patreon world. Your funding helps to support all of this. Anyhow, I like to show it off. It's cool. By the way, if you would extend this out, you know, if we had a 7 and 8 day forecast, yeah, I think this could be a problem for the United Kingdom. So Will and Chris over there, David, I think David Edmonds, if you don't mind me calling you by your last name. I'm trying to remember everybody. We've got about 900 and something current active patrons, and I absolutely love the fact that we have such awesome people supporting what I do, what we do, and I try to get to know you guys. But heads up, in the UK, you might have to deal with what's left over of Epsilon here. We will examine that part in just a minute. But first, for Bermuda, which is over here, remember Bermuda is not one island. It's made up of several islands out in the Atlantic. The core of Epsilon will pass well to your east, but it'll be wide enough with the wind field that you might get some tropical storm force winds. You absolutely will get swells that will emanate out, and you know how much I talk about this, you know, and it's because it is a big deal. Large ocean waves that emanate out from these systems create rip currents and crashing waves. Surfers, you guys love it, and gals. I've never surfed, but I get it. But look, I just want you to be safe. If you're dead, you can't watch these videos. And I'm not even being silly about that. We got to keep you alive. That's my number one goal. Keep you alive, keep you aware as to what is going on. So be mindful of the swells that will be heading your way in Bermuda. The same is true for the east coast of the United States, the Bahamas, and then all the way down here into the Lesser Antilles, portions of the Lesser Antilles, the Greater Antilles as well. And this is reflected in the products from the National Hurricane Center. It's not just Mark being some nervous Nelly like a good dad would be, right? I mean, it says it. We can read the public advisory. Come on. Under hazards affecting land. Some tropical storm conditions possible, maybe late Thursday, yes. But I'm more worried about this part right here. Large swells generated by Epsilon are affecting Bermuda, so it's already there. Howard, go down to the waterfront and tell us, do you see any swells? Howard's another one of our supporters. He's in Bermuda. I wish I could go to Bermuda. Stupid virus. I can't wait for that to not be a thing. I think we can all agree to that. But anyway, Bermuda, the Bahamas, the Greater Antilles, etc., just like I showed you. But look, I'm not just, trying to drum up concern where there is none. My wife works in the ER, and she tells me that, in the summer when we get these big waves, every once in a while she'll have somebody come in with a neck injury. Those big waves crash on you and you slam your head, hey, that was a good sound effect, into the sand, and you break your neck. You have neck problems, back problems. Just be careful. That's all I'm asking. Water temperatures are still in the 70s and 80s along a good deal of the southeast coast, certainly down in Florida. And I know they are down in the Antilles. Sorry, lost my train of thought. And tomorrow we will take a peek at what's happening down in St. Thomas, because that camera faces the ocean directly. We'll check in on the St. Thomas cam. So be mindful of that. In the Atlantic Basin, Epsilon is going to be generating a huge area of swells, kind of like that, but not really. You get the idea, though. All right, so let me go back real quick. So let's click on it. Epsilon as of 2 p.m. Atlantic Standard. Let's call it 30 north, 60 west. We'll just round these numbers right here up. Again, way to go, Will. Way to go, buddy. This unbelievable coding that you have done. I owe you a tremendous debt, not only of gratitude, but eventually we're going to make you a part of the staff, buddy. I'm working for that. We're going to make it happen. Several people. We'll talk about that later, but it's coming. Good job, Will. Seriously. So 30 north, 60 west. Easy to kind of figure out here. Let's use the purple again. There's 30 north, and there's 60 west right there. So Epsilon, I'll highlight that in white, is located roughly right here, right now as we speak. So it's leaving the sensible, in other words, that you can feel, upper ocean heat content. Is going to drop to near zero. But that doesn't mean the water temperature is zero, or that the water temperature is below 26 Celsius. I mean, it might be, but it's still going to be warm enough as Epsilon travels this way and then turns the corner. And the other dynamics that I talked about, that colder upper atmosphere through here, the well-ventilated outflow that you saw in the satellite animation over here, all of that's still going to be in place. It's got a great umbrella to live under, to continue to strengthen, and I am a firm believer. I'm going to be stubborn about it. I'm going to get my 120, and I might even be a little bit low. So let's take a look at the GFS, and this is going to be interesting. Watch the vorticity signature of the core in here, and notice how it changes. It's these subtle changes. People look at different parts of the models to figure out what's going to happen. And I talk about this often. This is how Mark Sudduth does it. It doesn't mean that I am right. It doesn't mean that other people are wrong or whatever. And how the Hurricane Center does it, I have no idea. Like, I don't know their true, and I bet there's a protocol. I bet there's a, they look at moisture, they look at rapid intensification parameters, and they've got an entire forecast based on it that has to be logged and scrutinized and judged and then it becomes part of the permanent record forever. And so there's a lot more riding on it than a guy with a website here like me and a fairly popular, in the scheme of things, YouTube video. I mean, keep things in perspective. But I do know what I'm talking about enough that I can look for little clues. And I'll show you one of them today. I'm going to let you in. It's not a secret, but this is what I look for, and I think this is really neat. So here it is now. And you notice that structure right in there where the vorticity is most concentrated around that central dense overcast. That solid black, deep red, whatever, that is that right there. All right? And then the rest of this, the vorticity and the way that the height fields are in the atmosphere, is a little bit loose, more loosely organized. You see these height lines in here. Probably should use black so they stand out better. Well, no, then they're the same color as the height lines. It's just there's more energy getting packed in here. That's the easiest way to describe it. So let's move on because I want to show you what I'm thinking of. So this is valid a couple hours ago. This is 18Z from the 0Z, I'm sorry, the 12Z run today, valid at 18Z today. All right, I'm so excited to show you this that I get a little ahead of myself. So let's move it out into time. Watch that little ball in there. It's a little oval shaped, whatever. We're now out at 24 hours. It's just east-southeast of Bermuda, but watch what happens right there. This point right through here, it becomes like there's just a certain look to it. You know what I mean? It like really just becomes better defined. That's the way I look at it. And the model, the GFS, is seeing that, the way it's modeling in its physics and its algorithms and all that. It's sensing that. And you can just see it kind of looks like almost like a triangle there. See that shape right there? It's almost like a triangle. It's hard to draw. But then it almost reaches that perfect symmetry here and there. And it even shows kind of like the center of it. The eye shows up really well right there. So yes, it'll be moving over colder water once it gets past Bermuda, but it just looks like it tightens up just a little bit more. You see that? And I know I might be like, you've been staring at it too much. But it goes from where it is now, it just looks more formidable. That's the way to describe it. And I believe that that's the GFS seeing that central dense overcast, the core of it, whatever, and it's got a grip on it. We give the models a lot of heck that they don't know what they're doing, they're blah, blah, blah. But sometimes they just get it. And everything's working right, and the physics of the model is in there, and it's just humming. I mean, people put these together. These are produced, coded. We're talking about coding what Will Woodgate's done. I don't know who codes the GFS, but my goodness, that's got to be a lot of responsibility. And they try to get it right, and I think in this case, I don't know, I'm just hooked on it. It's neat to me. I believe Epsilon will get stronger. And you know what? I'm going to go out on a limb. It won't shock me if it makes it to 130. I'm still going to say 120, but don't be surprised if you look at it and it's a beautiful 130 mile per hour hurricane tomorrow. So there you go. All right, what about the future? You notice I didn't show you much else because there's not much else going on, which is great. Ooh, but before I do that, I almost screwed up because I wanted to show you how this might affect our good friends over in the UK. I can't leave you hanging. I'm sorry, I got too excited about everything. I enjoy doing this. You guys know that. To me, this is not a job. It is my income, but I love what I do, and sometimes I get ahead of myself. So that's 72 hours that we showed you. We're on the wide picture here just to give you an idea of what's what. Hadn't had to show the wide shot in quite a while. There's Ireland, and here's the western portions of, what would you call it, just England proper? But the United Kingdom as a whole over here, I guess that's part of France right there. There's Spain and Portugal. Let's just make this easy. Watch the purple area. That's the UK, okay? The United Kingdom as a whole. So 96 hours, there it is over the North Atlantic, well to the south and east of Newfoundland, and then off it goes, kind of mixes up with another storm system. So I'm just saying, we got to watch and see. It does get tangled up with another storm system up over the North Atlantic. That itself may become extremely powerful. And if this pinwheels over towards the British Isles, the UK, I guess I got to talk to Will and Kari and find what the heck which one's which? You got Ireland, you got the Scotland, you got England. I guess the whole thing's the United Kingdom, but I'm a geography major. I mean, that's what I got a degree in. You'd think I'd know, but I don't know everything. But look, this is incredible how it kind of pinwheels the energy from Epsilon in there. And then the whole thing, eventually makes landfall, if you want to call it that, in Iceland. Can I go to Iceland? Are they not allowing people in? I don't know. I'm just kidding. All right, so we'll keep an eye on it for the UK and beyond. Now, what about the future? So I picked this up from Cyclonic Fury, just somebody that really likes to talk about the tropics, 500 followers on Twitter. Maybe you'll have more after I show this. But I like to pick up on what other people say. I talk about that often, and here's an example. So, Cyclonic Fury says, climate models such as the CFS, which is the Climate Forecast System, are indicating that November may be much more favorable than normal for tropical cyclogenesis in the Atlantic Basin. Why? Why would Cyclonic Fury say such a thing? Well, it's not hogwash, because this is what... I mean, maybe it is because the models are wrong, but it's not like this person is making stuff up. Here's the output. It's from a reliable source. I mean, come on, it might be happening. We'll see. And you can tell that the overall shear looks like it's going to be lower than what we're expecting. These blues here are anomalously low shear vectors in the deep tropics, the Caribbean. That's where it's really going to matter. The other graphic, the overall upward motion, green for the most part, according to the CFS at 200 millibars, way up high in the atmosphere. Generally speaking, green is favorable for the air to do this, to go up and out instead of converge and sink. That's what the green generally shows you. I needed to get in there and kind of demonstrate that for you. That's an easy way to do it. Whoops, trying to get rid of the telestration, and I came back. There we go. And then the other one that Cyclonic Fury was mentioning is, this is also reflected in the EPS guidance, which is the ensemble prediction system from the Euro, indicating strong negative velocity potential, that's up at 200 millibar, anomalies over the Atlantic during early November. And the easiest way to describe this to you and explain it, let's use black, and it's got some opacity, so that helps. Here's where we are now. And this is the area that we're talking about, down in the deep tropics. And going forward, this is the future, down this way. You understand? So looking ahead at the end of October through about mid-November, a very robust signal right in here, stronger and stronger upward motion favorability where? Across this region right through here, roughly, which is the deep tropics through roughly the eastern to central Caribbean. That's what this shows. And that's the Euro, the ensemble prediction system. That's the ensemble mean there. Pretty big signal. It's not going to surprise me. You've got that sort of model where the GFS whiffed, the model whiff. Something whiffed on something. You really screwed the pooch there, GFS. It was showing a hurricane. Yeah, we'll give it a pass, okay? The models have struggled this year, but that kind of a signal from the EPS, indeed, we need to watch that. Wrong Way Lenny, 1999. That was kind of a La Nina-ish year. I got to go back. I think it was. Anyway, bottom line is as we end October and get into November, probably are going to have a couple more developments. And it won't surprise me with all the warm water that's out there and the La Nina in place that we get one or two more hurricanes. And we will break the record of the most named storms in any hurricane season. Yes, I know some of them have been sort of 12-hour named storms. I get that. But who freaking cares? It's just neat to watch, I think. And we've had 10 hurricanes with Epsilon. Can't argue that. And if it becomes a major, I think it'll be the 4th major hurricane. And that's slightly above average, I think. Maybe a little bit moderately above average. And yes, I believe we will add a couple of more. All right, there you go. As always, thank you for tuning in. I do appreciate it very much. Remember, I'm on Twitter, @HurricaneTrack. That's the brand. It's HurricaneTrack. Hurricane, T-R-A-C-K. Say it to yourself, HurricaneTrack. That's the brand. Look for the logo, the red, black, and white logo. Also, Patreon, that's how we fund what we do. If you ever want to get involved, the door is always open, and we would appreciate it. Have a great rest of your Wednesday. I'm Mark Sudduth. Again, thanks for spending a little bit of your time today with me. I'll talk to you some more tomorrow.